Good day. Today we are going to discuss independent t-test. So this will serve as the supplementary file for our lecture. So last time we discussed the statistical framework that we're going to follow if to decide what kind of statistical test that we're going to use. So this is now the application part. So let's try to analyze an example study here. This is just a hypothetical study that I randomly made. So for example, if your study is about the comparative study on the satisfaction level of university's basketball court between male and female students. So your conceptual framework here will look like this. So you want to measure the satisfaction level of the university basketball court with respect to the sex of the students, if it is male or female. So your statement of the problem will probably look like this. What is the satisfaction level on the university basketball between male and female students? And then after you identify the level of satisfaction for both male and female students, we want now to identify, is there significant difference? So this is the statement problem number 2. Is there significant difference on the satisfaction level on the university basketball court between male and female students? So we want to know if there is a difference, significant difference on their satisfaction level. So from this statement of the problem, we have our hypothesis. So there's only one hypothesis here. So there is no significant difference on the satisfaction level on the university basketball court between male and female. That is our null hypothesis. So our null hypothesis states that there's no difference. So we're going to test this one if the null hypothesis will still be true. So this is very important. Last time we discussed the statistical framework. So if we follow the framework here, and let's go back to the framework that we've discussed. So how many dependent variables do we have in this kind of example? So the dependent variable here, this one is the dependent variable, and this portion here is the dependent variable, independent variable. So how many dependent variable do we have? There's only one, the satisfaction level of the university basketball court. What type of variable? Yung dependent variable natin. So our dependent variable here is satisfaction. So we can express that one later, and if we get the average of all the values here, we can express that one as a continuous. So it's continuous. And then how many independent variables do we have in our study? In this case, there is only one. There is only one independent variable. By the way, guys, the framework that we are using in this classroom is, we adapted this one from the book of Andy Field, the Discovering Statistics Using SPSS. So the question here is, how many independent variables do we have? So there's only one independent variable, the sex of the students. Okay, so what type of variable is our independent variable? So from our previous discussion in the beginning of the semester, the sex of students are male and female. So that's the categories. So this is a categorical variable. So if categorical variable, how many variables do we have? So we only have two categories. We have the male at saka din female. So in this case, so the direction here is from one continuous, the categorical, and then we only have two categories for our independent variables. We are looking at this. So the next question here is, this is the tricky part. If categorical, same or different participants. So how do we decide this one? Question: if your respondents, if you're going to do the data gathering, the question here is, if your respondents, can your respondents answer, can you represent the male and then the female? Of course not, because if a certain respondent will only select if he or she is a male or a female. So in this case, we will have different respondents for male, and then we will have different respondents for the female. In the next topics that we have, the paired t-test, we will look at these examples that the same participants. Okay, but as of this moment, so we will treat this one as different, because there will be different responses who will answer for the male part, and different responses, we will answer for the female. So in this case, if 2 and then different, so this is now the question. Do the data meet the assumption of parametric tests? So if yes, if the data will follow the normality, the assumptions of parametric test, we're going to use the independent t-test. If it will violate the assumption of normality, we're going to use the Mann-Whitney test. So in this tutorial, we're going to run through all of that, and then we will also do the reporting. Okay? So without further ado, let's start. So let's now decide how are we going to. So in this video here, I also attach the data. This is just the data that I use to analyze this problem, assuming that this is the result of your data gathering. So why is this? What's the light, the floor, the bench, the changing room, at saka the ring? So take note, guys, in your data gathering, when you measure the satisfaction level on the university basketball court, there are items there. There are items there. For example, in the basketball court, how satisfied are you with respect to the lights, to the floor, to the bench, to the changing room, and to the ring? Then all of these will compose your satisfaction level, overall satisfaction level on that particular basketball court. So in this case, if to get the satisfaction level, the overall satisfaction level of each respondents for the basketball court, so what we're going to do here is equals, and then the average, and then we have to average all of these responses here, and then we press enter, and then 5.4. This means that for the respondent number 1, the satisfaction level is only 5.4 out of 10. So 1 as the lowest, and then 5.4 as the highest, as in 10 as the highest. So in order to solve all of these, we're going to drag this small circle, this more square here, and then drag all of these, and then wait, yeah. Okay, so that is our the satisfaction level. So we also have another column here, the sex encoded, because in SPSS, guys, male and female, we have to use numerical values there. So we will encode your male as, let's say, 1, and then female as 2. So how do we encode this one? So there are many ways how to do this. So in my case, I prefer to use the semi-manual. So you copy all of these. Copy mo yan ng lahat. And then you paste it here sa encoded. Paste it here. Paste all the values here. And then you press in your keyboard Control H. Control H is the shortcut for replace. So find what? So for example, find what? Let's say female. Find what female, and then replace with 2. And then replace all. It automatically replace all the females with number 2. And then let's say the male, and then we will replace all the values 1. Replace all. Then all of them are already encoded. So we're going to need these values here. Yan na yan, to analyze it in the SPSS. So we have to copy all of the data here. Copy the data, copy that one, and then you proceed to the SPSS. This is our SPSS here. So you paste your data, and so in this case we still don't have a label, still variable 1 at variable 2. So we have to replace all of these. So we go to the variable view, and then the variable 1 is our satisfaction level, and then the variable 2, that is the sex of the student. So in this case, we're going to replace the variable 1 as satisfaction level. So this is the satisfaction here. And then the variable 2 as the sex of the students. So it's the sex. So also, in order for us to easily visualize the response of the male and female students, we can also change this one here. For example, 1 is the male, so go to the sex, the portion here, and then on the values here, 1 for male, add, and then 2 for female, and then add, and then just press OK. So when you go back to the data view, it is already male, female, male. So you can also click this one to change the value labels from the numerical to the words, okay, male and female. So let's start. Okay, so let's start our analysis here since we already encoded the data in our SPSS. So the first thing that we have to do here is we already decided that the direction of our statistical tool is we're going to use either independent t-test or Demand-Whitney test, right? So what we're going to do here is we will test the assumption for normality. If it will follow the assumption of normality, we will use the independent t-test. If not, we will do the Demand-Whitney test. So how are we going to do that? So this is the results. So in SPSS, go back here. By the way, in SPSS there are 2 windows. This is the data. This is the data view here, and then the other one is the output. So all of the outputs will be generated in this window here. Okay, so let's start. So how are we going to analyze this one? So analyze, then you go to the descriptive, and then explore, and then the satisfaction level. You put the satisfaction level here in the dependent. And then, oh, by the way, this is very important here. The variable. So the satisfaction level is a numerical. So we have to change this measure here. The measure as satisfaction, that's scale. In our previous discussion, the interval and ratio are categorized as a scale. In this case, the sex is the nominal. So, okay, so let's do it again. Analyze, descriptive, and then you go to the explore, okay, and then the satisfaction, the dependent list, and then factor list is the sex of the student. So do that, and then you go to the statistics. The statistics, okay, we will use the descriptive, and then the plots, and then although the stem and leaf displays we can get something out of it, but normally we don't need that for our test of normality. And then so we can click this histogram here, and then this portion here, if we click this one, we will test the normality of our data. So we click the normality, and then this portion here is the homogeneity of variances. So we have, although there are other assumptions for normality, but the one of the 2 important tests that we can have is the normality testing and the homogeneity of variances. So this is the normality, and then this portion here is we'll test the homogeneity of our variance using the Leven's test. So untransformed, you click this one, and then you press continue, and simply press OK. So this is the result. So very important, the most important part when you generate the data is you know how to interpret the results. Okay, so we will now try to interpret the results. What are these, and how are we going to, although we will not do all of this, just the basic. Okay, so the first is we need this one. So this one here, so the case processing summary. So and the n here represents the number of males in our data set. So for male, we have 216 males, and the females is 169. Okay, and then some of the descriptive statistics are here. The mean value, the 5.48, the mean value, the mean satisfaction level. This is the 5.48, and the mean satisfaction level of the females are 4.99. Or approximately 5. So this is the portion. This portion here will test the normality of our data. Okay, test of normality, and this portion here is the test of homogeneity of variance using the Leven's test. Okay, so let's try to analyze. In the book of Andy Field, he only used the Kolmogorov-Smirnov test. Although we can also take a look at the Shapiro-Wilks test. So, but in this case, we're going only to look at the Kolmogorov-Smirnov test. Okay? So what is the rule again? The rule is, okay, so let's continue. So how do we decide now if the data follows the assumption of normality and follows the assumption of homogeneity of variances? So we're going to look at the Kolmogorov-Smirnov here. So we will take a look at this the sig value. The sig value stands for the significant value. Okay, so this we will follow this guideline here. So although there are some books who use the null hypothesis, express this one as a null hypothesis, but to make it simpler, so we're going to follow these guidelines here. So for normality testing, if the significant value is greater than 0.05, we can say that the data does not significantly differ from normal distribution. Does not significantly differ. This means that our data follows normal distribution. Normal. Okay? So if the significant value is less than 0.05, so the data significantly differ from normal distribution. So in other words, this is not normal. Okay, if we're going to take a look at this portion here, the significant value for male and female are both greater than 0.05. So, greater than 0.05. So, ibig sabihin niya, this is greater than 0.05. So, the assumption for normality is met. So, 0.078 and 0.09. Let's proceed now with the homogeneity of variance. Let's check the variance for male and female. So we're going to take a look at the based on mean. So based on mean, 0.132 here. So if we're going to take a look at our guidelines here for the variance, if the significant value is greater than 0.05, the variances do not significantly differ from each other, or we will assume that the variances are equal. And then if the significant value is less than 0.05, then the variances significantly differ from each other. Okay, so since the value here is 0.132, so this is greater than 0.05, so we can assume that the variances are equal. Okay, so this means that for the tests of normality and the homogeneity of variance, our data meet the assumption, the parametric assumption. Okay, so if we're going to take a look at here, so yes, since all of them follows the assumption of normality and the homogeneous variance, so yes, so we can now decide what statistical tool are we going to use. So we're going to use the independent t-test here. Okay, so decision pa lang yan. What statistical tool are we going to use? So we will now proceed on how to do independent t-test. How to do independent t-test in this example. So let's go back to our SPSS. So here, so how we're going to do the independent t-test. You go to the analyze, the script analyze, and then compare means, and then independent sample t-test. Okay, and then the test variables here, the dependent variable, that's the satisfaction. And then the sex, we're going to put up the grouping variable, and we have to define the group 1. The group 1 here, the number 1 for the male, and group 2 for female. And then continue, and let's check for the options, the 95%, and then the bootstrap, we don't need that in this case. So press OK. Press OK. So the result is here. Okay, so this is our result. So we only need some portion here. So let's go back to the Word file that we have. Okay. So by the way, but before that, we have to report the assumption. So how did we report the assumption? For the normality, to properly report it, the satisfaction level of male D. So when you do Kolmogorov-Smirnov test, the symbol is D. This 216 that's the degrees of freedom. Where did we get that one? Here in our normality test. So this 216 here is the degrees of freedom here. And then the result of that statistic, 0.058 here, the statistic for the Kolmogorov-Smirnov. And the P is less than 0.05, greater than 0.05, since our sig value here is 0.078. So that's greater than 0.05. And for the females, so the degrees of freedom, this is the degrees of freedom, this is the statistic, and then it is also greater than 0.05, which is 0.20. So do not significantly differ for the both data, do not significantly differ from normal distribution. For the homogeneity of variances, okay, for level of satisfaction, let's proceed. So the variances were equal F, that's a symbol for the homogeneity of variance or the Levene's test. So F, this is the 2 degrees of freedom, 1, degrees of freedom 2. So degrees of freedom 1 is 1, and then 383 for the degrees of freedom 2. And then the F value is the 2.283. Let's put it here. And then the P value, or the sig value is greater than 0.05. The sig value here is 0.132. So greater than. So the tool, this is the conclusion for the statistical tool. Since the satisfaction level for the male and females are normally distributed and have equal variances, hence the researcher used independent t-test. Okay, so for the result of the parametric test, we already did the independent t-test here. These are the results. So we will now interpret these results here. Copy natin yan. So this is the mean. We are going to need this one, the result. Okay, and then for the independent t-test, we have to copy this one. I only crop up to this point because we only need, for this moment, we only need this portion here. Okay, so let's continue to analyze. So the results should answer our statement of the problem. Take note. So the statement of the problem here is, what is the satisfaction level on the university basketball court? So what is the satisfaction level? So in this case, we can already solve the satisfaction level. The satisfaction level for male is this portion here, 5.48. And then for female, 4.99. 4.99. So the next question here is the next question here is, for our problem, is there significant difference? Since there is already a difference, so the question is there significant difference on their satisfaction level? So we are going to use the t-test to answer that question. So the t-test, so this is the result, the t-test. So this portion here is just same as the result of the Levene's test, the homogeneity of variance here. But it is good that it is placed here so that we can easily see which two values, which two rows are we going to see. Okay? So in this case, the sig value is 0.132. Last time, we have this one, a rule that if the sig value is greater than 0.05, we will assume that the variances are equal. So in this case, since this value here is greater than 0.05, so we are going to look at this row here. If this value here is less than 0.05, so we're going to look here. Okay? So since the variances are assumed to be equal, so dito tayo titingin. The sig value is 0.0. Sig value is 0.0. How do we interpret this one? So we're going to take a look at our guide here. So for independent t-test, if the significant value is greater than 0.05, the mean satisfaction level does not significantly differ from each other. There's no significant difference. If the sig value is less than 0.05, then the mean is significantly differ from each other. So in this case, in our example here, what is our sig value? our sig value here, let's take a look at this portion here, kasi this portion here is the Levene's test. Okay, so this portion here is the independent t-test. So this portion here, since the variances are assumed equal, so our sig value is 0.000, which is less than 0.05. So less than 0. Yeah. So it means that the satisfaction level for male and female students significantly differ from each other. Okay? But the next question is, what is the how big is that difference? Is it really very what's the effect of that difference? Is it really that negligible, or is it moderate difference, or it is very big difference? So in order for us to decide, we are going to use this effect size here. Okay, the effect size. So this is the formula of the effect size based on the book of Andy Fields. So the R, this is the R here, and then the T is the T statistic here, the T value here, and then the DF is the degrees of freedom here. We simply substitute the values there, then we can get the 0.2. And then we will adapt the Cohen. So sabi niya, if the R is within 0.10 to less than 0.30, small effect pa yan. Other literature states that if the value is less than 0.10, it has a negligible difference. Okay? If the value is within the range of 0.10 and 0.30, hence the effect is a small effect, small difference. There is a small difference. If the value within the range of 0.30 to 0.5, we can say that there is a medium effect. However, if the computed R is greater than 0.5, we can say that there is a very big difference, significant difference. Okay, so in this case, in our example here, the R is 0.2, so we can say that it has a small effect, a small difference. Okay, a small difference on the satisfaction level between male and female students on the basketball court. So how do we conclude this one? How do we conclude? So on average, the satisfaction level on the basketball court, of male, M, the M here, this is the mean value from the result. This is the mean. It's very important to identify the mean. Okay, kasi our mean here, as what we can say, the mean for male is slightly greater than the female. Their satisfaction is greater than female, which is M is equal to 4.99 or around 5. This is the error, the standard error mean. Okay, we have to report also that. And the difference was statistically significant. There is a significant difference. However, if we're going to include the size effect, there is a small size effect, but significant difference between the satisfaction level of male and female students. Okay, so this is how we conclude the independent t-test. So in next video, next topic we're going to discuss, what if we will assume that the data does not follow normal distribution? How are we going to do that? Okay, so we will use another test for that. Okay, so if you have some questions or clarification, you can comment down below, and then I will try to answer your question. Okay, so thank you.